Well, today we're going to be learning about similar triangles. And these are the content standards and the mathematical practices we'll be using with our assignment today. Previously, you've used angle, angle, side, and side, 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 and side, angle, side congruence theorems to prove triangles congruent. Now we're going to identify similar triangles using the angle, angle similarity postulate and the side, 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 and side, angle, side similarity theorems. We're also going to use similar triangles to solve problems. First of all, we have angle-angle similarity, and it is a postulate that says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So we're to use the angle-angle similarity postulate in these practice examples. We're to determine whether the triangles are similar, and if so, write a similarity statement and explain our reasoning. Well, since the measure of angle B is equal to the measure of angle D, that means that angle B is congruent to angle D. By the triangle sum theorem, 42 plus 58 plus the measure of angle A is equal to 180, because the sum of the interior angles of a triangle are 180. So that means the measurement of angle A is 80. So since the measurement of angle E is 80, that means that A is congruent to angle E. So triangle ABC is similar to triangle EDF by angle-angle similarity. Let's look at another one. We're to determine if these two triangles are similar. Notice we've got vertical angles here. Angle XQP is congruent to angle NXM by the vertical angles theorem. So since QP is parallel to MN, angle Q is congruent to angle N. So triangle QXP is similar to triangle NXM by angle-angle similarity. So time for you to check your progress. So pause the video and work the problem, then come back and check your answer. Did you get yes that they are similar? 86 plus 42 is equal to 128. So when we subtract that from 180, we find out angle H is 52. And by the same token, 52 plus 42 subtracted from 180, that means 180 minus 94 is 86. So yes, we've got all three angles. Let's check this one. So pause the video for a moment and come back and check your answer. And yes, it is. We've got vertical angles and we've got alternate interior angles. So by angle-angle similarity, we can say that these two triangles are similar. You can use the angle-angle similarity postulate to prove the following two theorems. We've got side-side-side similarity and side-angle-side similarity. So pause for a moment and read through those. And now we have the proof of theorem 7.2. So pause the video for a moment and read through this one. Now we're going to use the side-side-side and side-angle-side similarity theorems. So determine where the triangles are similar, and if so, write a similarity statement. So let's look. AB, we've got 9 over 6. That gives us a scale factor of 3/2. AC, 6 over 4, as again 3/2. And BC over EC, we've got 7.5 over 5. That is also 3/2. So we can say that triangle ABC is similar to triangle DEC by the side-side-side similarity theorem. Now let's determine if these two triangles are similar. Notice we've got a triangle within a triangle, so this looks a little different than what we've been used to seeing. Well, by the reflexive property, we could say that angle M is congruent to angle M. And now we're wanting to use sides that use M as part of their measurement. That's why we're doing it the way we are. So we can say that MP is to MS, so 12 over 12 plus 18, and then again we're going to use MN to MR. So 10 over 10 plus 15, and we get 2/5 for both of those. So we have side and the included angle and the side. So since the lengths of the sides that include angle M are proportional, triangle MNP is similar to triangle MRS by the side angle side similarity theorem. Okay, now time to check your progress. So pause the video for a moment, then come back and restart it and check your answer. So the answer is B. Did you get a scale of 1/4 for each of those sides? Angle R is congruent to angle R. We've got some vertical angles here, and QR is to QT as PR is to PS. So I got 1/4 for both of those. Very good. Let's move on. Let's try another one of these. So pause for a moment and then come back and check your answer. This one almost looks like it's not going to work because, okay, first of all, angle A is congruent to angle A. Then we're looking at 9 over 9 plus 4.5, or 13.5, is to 10 is to 15. But if you notice, we've got a number and half that number, a number and half that number. So we end up with a, if you put it in a decimal, 9 divided by 13.5 is 0.66 repeating. And 10 divided by 15 is also 0.66 repeating. Now you can decide what is sufficient to prove that two triangles are similar. So looking at example 3, if these two triangles are similar, and we're given that RS over XY is 2/3, which of the following would be sufficient to prove that the triangles are similar? So you're given 2/3 and asked to identify which additional information would be sufficient to prove that those two triangles are similar. Well, you know that these two sides are proportional with a scale factor of 2/3. Now we look at each answer choice until we find one that supplies sufficient information to prove that the two triangles are similar. Let's look at choice A. If RT over XZ is equal to ST over YZ, as choice A says, then you know that the other two sides are proportional. You do not, however, know whether the scale factor is 2/3. We know that RS over XY is 2/3, but we're not given what this scale factor is, so we don't know if all three sides have the same scale factor. So this is not sufficient information. Now we're told that all three of these sides are proportional, so we know they have the same scale factor of 2/3. So this is sufficient information by side-side-side similarity to determine that the triangles are similar. So we found our answer, and we will move forward. Time to check your progress. So pause for a moment and read through this and find out which one of these would be sufficient to prove that the triangles are similar. Very good. If you're told that AC is to DC as BC is to EC, we know that these two are vertical angles, so we would have enough information to prove that they're similar if we were given this information. Properties of similar triangles. Like the congruence of triangles, similarity of triangles is reflexive, symmetric, and transitive. So now we're going to use parts of similar triangles. You might want to sketch this on your paper because it's going to vanish here in a little bit as I move forward. So pause for a moment and sketch this information down. So we're told that RS is parallel to UT, and angle SRQ is congruent to angle UTQ, and angle RSQ is congruent to angle TUQ because they're alternate interior angles. So by angle-angle similarity, we can say that these two triangles are congruent, or similar. Using the definition of similar polygons, we can say that RS over TU is equal to RQ over TQ. So the measurement of RS is 4 and TU is 10. RQ is x plus 3. TQ is x plus 10. So we're going to use cross products. distributive property, and then solving for x. We're not quite done though. We were asked to find out what the measurement of RQ and QT are. So we substitute a 5 in for x and find out that RQ is 8 and QT is 20. Awesome. Now time for you to check your progress. So pause for a moment, then come back and check your answer. Did you get 14 is the measurement of AC? Well, I showed that AB over DE is equal to AC over EC. Okay, those are my x's that I'm trying to solve. So then I use cross products. I end up with 38.5x plus 77 is equal to 33x plus 88. Then I subtract 77 from both sides, subtract 33x from both sides. I end up with x is equal to 2. When I go back and substitute, 3 times 2 is 6, plus 8 is 14. Now we're looking at some indirect measurement, and we've been doing some of this since 7th grade, setting up proportions. You might take just a moment to draw a sketch of what you're given and pause and read the problem for a little bit. Okay, in shadow problems, you can assume that the angles formed by the sun's rays with any two objects are congruent, and that the two objects form the sides of two right triangles. Since two pairs of angles are congruent, the right triangles are similar by the angle-angle similarity postulate. So the following proportion can be written. The height of the tower over its shadow is equal to the height of the light pole over its shadow. Just substitute in the values. Use cross products property and simplify and solve for x. So in this instance, the Sears Tower is 1,452 feet tall. You can check your answer by substituting back in for x. Okay, now time for you to check your progress. So we're to find the height of the Cape Hatteras Lighthouse to the nearest foot. So pause for a moment and then come back and work your problem. 196 feet. Well, one of the things I did was I changed everything to inches because I had feet and inches. So I set up 66 inches is to 18 inches. So the 5'6" is to the 1'6". So 66 inches is to 18 inches as x is to 642 inches. I ended up with 18x is equal to 42,372 inches. I divide both sides by 18. I end up with 2,354 inches. When I divide that by 12, 196.16 feet. And they say round to the nearest foot, so 196 feet is the answer. Okay, here are our concept summary. Wrapping it all up, the angle-angle similarity postulate, side-side-side similarity theorem, and our side-angle-side similarity theorem. You're now ready to begin your assignment.